All right, so let's take a look at this understanding of work real quick. We're going to do just a quick demo with this box here, and then we're going to do a problem. Okay, so the first thing we need to remember is work is positive if the force and the displacement are in the same direction. And when I say in the force, I mean the parallel component, so roughly the same direction. If they are in opposite directions, again, this is a parallel component of the force, is in the opposite direction of the displacement, we end up with negative work. Again, positive, we're adding energy. Negative, we're removing kinetic energy. And then lastly, if they are perpendicular, no work is done. So let's kind of do a quick estimate here. So all I need you to think about is this positive, negative, or zero. All right, so as I push this box, I am doing positive, negative, or zero work. Positive, because I'm moving the box in the same direction I'm pushing the box, okay? Now if I turn around and push it back the other direction, I'm applying a force in the same direction it's moving. Positive work, I'm giving it energy. Well, why isn't it speeding up then? Why is it moving at a constant velocity? Because as I'm putting energy in, friction is applying a force in the opposite direction to the displacement and removing that energy. So what about gravity? What about the normal force? What kind of work are they doing? So normal force, gravity is pointing down, displacement is this way. Those are perpendicular, so 0 joules. How about the normal force? Perpendicular again. Let's try this some more. So as I lift it up, what kind of work am I doing? Positive work, because I'm applying a force up and it's moving up. How about what kind of work is gravity doing? Negative work, because gravity is pointing down, but the box is moving up. And as I lower it, what kind of work am I doing? Negative, because I'm applying a force up, but the box is going down. What kind of work is gravity doing as I lower it? Positive work, because gravity is pointing down, the box is going down. So we have to think about, are they the same direction or the opposite directions, okay? If I was to do positive work on the way down, I would need to be pushing it down. So essentially throwing the box down, then I would be doing positive work on the way down. All right, so let's take a look at the example here at the bottom. Gardener slides a 3 kilogram flat of geranium seedlings at a constant speed for a distance of 2 meters across a level table with a coefficient of friction of 0.3. All right, so they told me mu, so I should be able to find force of friction based on finding the normal force. Oh my goodness. And then once I find the force of friction, I could find the applied force. All right, so we can do basically a force problem like last chapter, but what else are they asking me to find? What is the work done by the applied force? What is the work done by friction? What is the work done by gravity and the work done by the normal force? And what is the net work done? All right, so first step is I want to find the work done by my applied force. So I need to know what is this applied force, and then I need to multiply it by the displacement. So here we go. So we typically call this work in because it's typically an input energy from an applied force. And it's going to be the force parallel times the displacement. I'll note my force parallel was not given to me, so I'm going to have to find it. Now there was a key word in there, constant velocity, meaning when I sum up those forces in the x direction, I get 0. Same in the y direction. So the sum of the forces in the x direction, I have F minus force of friction equals 0. So I can figure out what F is if I can find the force of friction. And what is our little motto there for force of friction? Substitute, 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 especially when we're dealing with this kinetic. So I have mu times the normal force. Where can I find the normal force? The y direction. So I have normal force minus mg equals 0. Normal force equals mg. So F is equal to mu mg. I can then plug this in as my force over here, multiply it by my displacement, 2 meters, and I should get a value of 17.64 joules. Now I want to find the work done by friction. Okay, so the work done by friction is going to be the force of friction, or the parallel component of it. Well, it's parallel to my displacement, times the displacement, and I actually get negative 17.64 joules when I plug in my mu mg with the negative sign on it here, times the displacement of 2 meters, I get a negative. What is that kind of telling me? All the energy we're putting in friction is taking out. That's why it's moving at that constant speed. All right, CS, how much work is gravity and the normal force do? Both of those do 0 joules because the normal force is perpendicular to the displacement and gravity is perpendicular to the displacement. Whenever you write 0 joules like this for a work, I'd really like you to get in the habit of writing this out. Why is that happening? If you're unfamiliar with those 3 dots, if they're 3 dots like that, it means because. If we flip it around and make it more of a pointy triangle of 3 dots, it means therefore. Little math lingo there for you. And then lastly, D says what's the net force, so I just need to add all those up, and I get 0 joules, meaning that it is moving at a constant speed. The kinetic energy is not changing. There we go.